Hello and welcome to the video. My name is Nick Lapham from Bristol Ground School, and today we will be covering how to interpret an ILS approach plate. Now, the plate that we will be looking at today is the ILS or localizer approach to runway 07 at Stuttgart. Now, there's nothing particularly special about this plate. I just picked one at random just to talk through some of the symbology that you'll see on the plate and talk through a little bit about how you'd actually plan to fly this particular approach. So a good place to start would be just to understand the format that these plates come in. So right from the top, we've got our communications section, and underneath that we've got approach briefing information. And then to the right hand side we've got our minimum safe or minimum sector altitude. We've got the largest section of the plate, which should be our approach plan view, and then beneath that our approach profile view. And then we've got some conversion tables and some icons, and then right at the bottom we have our landing minimums. So the plan is just to talk through the plate sort of from top to bottom. If you were briefing it, you would brief it from top to bottom, but I'm sort of going to go in what I think is a logical sequence. So up in the left hand corner we've got this code EDDS, so that is the ICAO identifier for Stuttgart, and then on the right hand side STR, that would be your IATA code. And then it's written GSPRM, so that stands for the Jeppesen General Student Pilot Route Manual, which is where I've taken this chart from. And you'll notice that the date here is the 18th of August 2017. That was the chart revision date. So this chart will probably be well out of date by the time you watch this. And as the pilot, it's your responsibility to ensure that you are using charts that are up to date. In this case, since this chart has come out of the Student Pilot Route Manual, it should be dated to 2017 for examination purposes. And here we've got the index for this particular chart, which is 11-1. There's nothing particularly unique about this code either. So if it's written 11-, that implies that it's an ILS approach plate. You might have some other ILS approach plates for Stuttgart, in which case they'll be 11-2, 11-3 probably. And then this particular plate serves the ILS, or if the glide slope is not operational, we could fly the localizer approach to runway 07. Now, along the top we have our communication frequencies, and these are usually laid out in the order that you would use them. So the first being your digital ATIS with a frequency of 126.125. You can see there's a star there. So what does that star mean? It means that that service is not operational 24 hours. Next frequency we've got there is for Langen radar. We've got another one for Stuttgart director, so that probably depends on how busy things are, because that's also got a star next to it. Then we've got frequencies for Stuttgart tower, and we've got a ground frequency as well. Now, along the briefing strip we have a frequency for our localizer, which has a designator India Sierra Tango Echo, and that would be 109.5 megahertz. Our final approach course will be 072. And then here we have a crossing altitude for our glide slope. So by the time we reach this point, 3.9 DME from ISTE, we should be at 2,500 feet above mean sea level, or this would be the height in brackets 1233. And then for the full ILS, our decision altitude is 1,467 feet, which would put that as 200 feet above the runway. And here we go, our airport elevation is 1,276 feet, and then our runway elevation is 1,267. So that would place this decision altitude at 200 feet above that. Okay, moving on from there. So we've got another little section which says our altimeter setting will be in hectopascals, but you can have that in inches if you require it. The runway elevation is 46 hectopascals. That's basically just to help you to make conversions between QFE and QNH. So if you took that 46 hectopascals and you multiplied it by standard pressure lapse rates, which should be in the order of 27 feet per hectopascal, multiply that out and you should get your runway elevation. Now the transition level is set by ATC and your transition altitude is 5,000 feet. And then it's always a good idea to look out for little notes like this. So we've got written in bold here, DME is required in order to fly this procedure. Now I've skipped the missed approach section. I'll look at that more towards the end of the video. And on the right hand side here we've got our minimum sector altitude. And that is based, this is important, that is based on Sierra Tango Golf VOR. So if we look in our plan view here, over there we've got that VOR that the MSA is referring to with the details. So it's identified as STG and it has a frequency of 116.85 megahertz. And then underneath you've got the Morse code identifier. Now, your minimum sector altitude is going to guarantee you 1,000-foot clearance of obstacles out to a distance of 25 nautical miles away from this particular VOR. And it's broken up into different sectors based on inbound bearings. So imagine, if you will, taking this circle up here and superimposing it on our plan view so that it looks something like that. Now what that will do is break up our plan view into different sectors. So if we were to the north of STG, for example, we would have an MSA of 3,400 feet. That's that figure up there. Or to the east, southeast, 4,200, and so on and so forth. Now there's a little bit of a complication here. If we were to the west of STG, our MSA is 3,900 feet, and then we've got a 1 in a solid circle. Now whenever you see something like that, the implication is that there's not enough space within that area of the chart to fit that information, which is why they've put it down here. And that says your MSA will be 3,300 feet if you are within 15 nautical miles. Now presumably if you're beyond 50 nautical miles, there's some taller obstacles out there, and that's why the MSA will go up to 3,900 feet. So if that wasn't clear, I'm just going to rather inaccurately draw a 15-mile boundary here. If this was to scale, it would be sort of way off the edge of the plan view. But that's just to give you an idea. So if you're within this section, your MSA would be 3,300 feet, and then beyond 15 miles, it's 3,900 feet. Okay, moving on from there. So the bulk of your approach plate will be your plan view and your profile view, which are both two-dimensional ways of looking at things. So your plan view will be looking at the procedure from top down, and then your profile view was almost as if you were looking at it side on. And so when it comes to imagining how you're going to actually fly the procedure, you kind of have to build a 3D image in your brain based on these two 2D images. Now, I'm just going to talk about the sort of conventional way at which you would arrive at flying this particular approach. So usually you would transition from the en route sector of your flight via a standard terminal arrival. Normally that would place you at what's called an initial approach fix, which if you look up here you can see in brackets it's labeled IAF, and then we've got Blueberg VOR. And if you look down here as well, we've also got another one that's labeled IAF, which is the Stuttgart VOR we were just talking about with the MSA. Now, which of these you're going to end up at depends on which procedure you use, probably which direction you've come in from. Now, I'm not going to show you all the different ways this can be flown, so I'm just going to imagine that we've flown a standard terminal arrival that has placed us at Blueberg VOR, which we can't actually see because it's off the edge of the plan view, but it is depicted here. Now, if we were at Blueberg VOR and we had not received an onward clearance for the approach, we would have to hold at Blueberg until we were cleared to proceed. And supposing that we were, what happens next? Well, we would fly down this medium thickness line 15 nautical miles to this point here, which is labeled 15 DME from LBU. And we would fly this direction along a magnetic track of 229. And the altitude at which we should be at is 5,000 feet. And how would we know when we've gotten to this point? Well, for one, it will be located along radial 229 from LBU at a distance of 15 DME. But we've also got this grey arrow, which is depicting radial 291 out from STG over here. So you could set radial 291 on your HSI and you would know when you cross that over. Now from that point we will fly another 6.7 miles continuing on 229, but we would now be descending down to 4,000 feet until we got to this point here, which is 21.7 DME from LBU, and it's also defined by radial 265 from STG. And then from there, it's going to be a left-hand turn to intercept the localizer, which should place you on your final approach course of 072, which will agree with what's written at the top here. Now, at the point at which you intercept the glide slope, that is the first point on this particular plate at which the profile view comes into view. And that would be at this point, which is called VARTA. Now that is defined as being 8.6 DME from ISTE, so that would be the DME that's associated with the ILS. And then we've got another DME figure, 9.2 from SGD. Now what's SGD? If you look over here, there's a DME symbol, and it's labeled SGD, and it's got a frequency attached and a Morse code identifier. Now, by the time we reach this point VARTA, we should be at 4,000 feet. And if you look over here, there's a little cross there called a Maltese cross. And what that is indicating is the final approach fix for the non-precision approach, i.e. for the localizer approach. Now, precision and non-precision approaches is sort of an outdated mode of classification. I'm still going to use it because I find it tends to be quite a lot simpler when it comes to explaining these things. So we should be at 4,000 feet by the time we reach VARTA. Now what happens next is largely going to be dependent on whether we're flying the ILS or the localizer approach. So we're going to start a descent. If we're flying the ILS, obviously that will be on the glide slope. We're descending while flying inbound on 072. And then we get to this point here, which is defined as being 3.9 DME from ISTE or 4.5 from SGD. And that is telling us that at that point we need to be crossing that point at 2,500 feet. And that would be the case for if we were flying both the localizer or the full ILS. Now, continuing on from there, I want you first just to imagine that we are flying the non-precision approach. How would we know that we were flying the right profile? Well, that's what this table at the top here is for. That's to give you guidance based on your DME from ISTE as to what altitude you should be crossing at 8 miles, 7, 6, 5, and so on and so forth. Now you need to pair the information that you're getting out of this table with information from this table down here. Now this table is going to help you to figure out what rate of descent you require for a given ground speed. So if we look over here, it says ILS ILS glide slope or localizer descent angle of 3 degrees. So a 3-degree approach is pretty standard for an ILS. And given the ground speed that we're flying at, perhaps it's 100 knots, we would require a rate of descent of 531 feet per minute. At the bottom here, we've got some information saying the missed approach point is at 0.8 DME from ISTE or 1.4 DME from SGD. So if we are following the right profile for our localizer approach, we would continue downwards like this, and you'll notice at the top here I've also included an arrow at the same time, and that would bring us to this point over here where you can see there's a little upward arrow, and what that's implying is that the aircraft has followed a 3-degree descent path down to its decision altitude. Now things get a little bit confusing when we start talking about non-precision approaches and whether they should be labeled as an MDA or a DA. From what we can gather based on how this profile view is presented, it's meant to be flown using a continuous descent final approach technique down to a decision altitude of 1,980 feet or 713 feet above the runway, and at which point, if you don't have the required visual criteria, then you need to execute a missed approach. There's a little note here as well, a 1 in a box. So if we go down here, that's telling you that it is only for aircraft up to 5.7 metric tons of max takeoff weight. So supposing we didn't have the required visual criteria to continue, then we would execute a missed approach from there. Now if you are flying the non-precision approach and you execute a missed approach, you need to still continue navigating towards this point here, which is labeled M. So that is the missed approach point. Now if you were flying a procedure that told you that within the missed approach procedure what you must do is turn left as quickly as possible, you could not turn left immediately after executing a missed approach, because that would probably put you outside of the protected area of the procedure. What you'd have to do is start climbing away but navigate towards the missed approach point, and then you would continue with the missed approach procedure. Now if we were flying the ILS approach, we would continue onwards down to a decision altitude of 1,467 feet, or a height of 200 feet. And there we've got another pull-up arrow. And that point there for the precision approach is the missed approach point. And that would be defined as the point of intersection between the glide slope and your decision altitude. So if you go around from your decision altitude on the on the full procedure, then you will go straight into following the missed approach procedure at the top here. Speaking of missed approach procedures, so the missed approach procedure says that we must climb straight ahead to 5,000 feet, and when crossing 7.0 DME from SGD, which also happens to be the same as 5.6 DME from STG, so when we cross those, or that point, or 5,000 feet, whichever is later, we must turn left to LBU VOR. Now what we can do is combine this information with what's written down here. So this little icon on the left hand side is giving us an idea of the approach lighting system that we're expecting to see. And then to the right hand side here, these are sort of your immediate actions for the missed approach, which is climbing straight up to 5,000 feet, and then we need to get to a point 7.0 DME from SGD or 5,000 feet, whichever of those occurs later. That's what we need before we begin our left-hand turn. And you can see that actual procedure is depicted on the chart here as a dashed line. There's the point 7.0 SGD before you start a left turn. And that will take you up to LBU, which would be the VOR that we started from, and it's depicted over here on the left hand side. So if we were going up to LBU, our next steps are probably going to be based on what air traffic control tells us, but it's assumed that you would probably take up a hold at LBU, and you've got a minimum holding altitude depicted here as 5,000 feet. Now, moving on from there, the last thing I'm going to talk about is your approach minimums. Now, if you are flying the ILS approach, as I've said already, your decision altitude will be 1,467 feet above mean sea level, or a height of 200 feet. Or if you're flying the localizer approach, your decision altitude is 1,980 feet, or 713 feet height. And the RVR that you require for the approach is going to be based on your aircraft categorization and the functionality of the approach lighting system. So you can see that the category of aircraft is not going to have an impact on the RVR, but if you've got the full approach lighting system, you require an RVR of 550 meters. If your approach lighting system is out, then your RVR will be 1,200 meters. And then the limited section in the middle, it's a little bit complicated, but basically if the system has been downgraded, then you require an RVR of 750 meters. And on the right hand side here, if we're talking about the localizer approach, for CAT A and B, your RVR is 1,500 meters, and then you can see down here it's not applicable for CAT C and D, which has got something to do with this little note that I read here earlier. Now, what approach category would my aircraft be in? Well, that's going to be dependent on your indicated airspeed at the threshold in your landing configuration at max certified landing mass. I'm not going to go into that too much, but I've put the information on the screen for you there. And then you've got your category A here with a speed of less than 91 knots, and then category B will be between 90 knots or more, but less than 121 knots. I think you get the idea of that. And that pretty much brings me to the end of the video. So I hope you've managed to get something useful out of this, and I'll see you in the next video.